This slide tells you how to find an inverse of a function. So we see the steps. We're going to interchange x and y, solve for y, and then put it back into function notation. So example 5 says, if the function is 1-to-1, find the equation of its inverse. So that word if is kind of important. If the function is 1-to-1. Okay? So I think the best thing to do is kind of imagine what it looks like. Part A, f of x equals absolute value of x. You should know that that's a V shape. Okay? And we know it's a V shape, and that tells me that it's not 1-to-1. And if it's not 1-to-1, then it's not going to have an inverse. So this inverse does not exist. We look at the next one, and of course 4x minus 7 is a line. Looks something like that. And so if you think about the horizontal line test, that function is 1-to-1. I know that it will have an inverse. So let's find the inverse. One thing that I think is missing from the steps is g of x is y. So really step 0 is put a y in there. So you can do step 1. Step 1 says switch x and y. And then we're solving for y. So we're going to add 7. And divide by 4. Y equals x plus 7 over 4. So in function notation, that's going to look like g inverse of x equals x plus 7 over 4. Now, I believe Math Excel is probably going to make you write that as 1/4 x plus 7/4. You need to recognize that that's the same thing. Okay, be prepared to enter it either way, but I like the blue way better. I think Math Excel likes the purple way better. If you look at part C, picture what part C looks like. X cubed is that disco function, and this one specifically is a disco that's been shifted up by 5. So horizontal line test shows me this is 1-to-1. I know this will have an inverse, so we should be able to find it. Switch x and y. And solve for y. So subtract 5. X minus 5 equals y cubed. Of course, in order to get that, get rid of the cubed, we're going to take a cube root of both sides. So y is going to equal the cubed root of x minus 5. Let's put it back into function notation. H inverse of x equals cube root of x minus 5. Example 6, the rational function is 1-to-1. And so the fact that they're telling me that it's 1-to-1 is telling me that there is an inverse. So we already know there's an inverse. So they want me to find it. So let's do the same thing. We have y equals negative 3x plus 1 over x minus 5. And x does not equal 5. So this reminds me of what we did last chapter. There's going to be an asymptote, a vertical asymptote at x equals 5. The domain, if we were looking at the domain, since we don't want the denominator equal to 0, we'd say something like all real numbers except 5. But let's continue finding the inverse. Switch x and y. So now, if we want to solve this, you've got two different y's, so we can't isolate yet. And plus, we don't like having a y term on the bottom. We don't want our variable on the bottom. So what I'm going to do is basically cross multiply. X times y minus 5 equals negative 3y plus 1. Distribute the x. xy minus 5x equals negative 3y plus 1. Okay, Now we're cooking. We need to isolate y, but there's still two of them, and so we have to get the two of them together. And so if that was a 4y, you'd know what to do. You'd add 3y to both sides, but it's an xy. Doesn't really matter. We're still going to do the same thing. We're going to add 3y to both sides. Okay. Now here's something that people are not good at. We have to do xy plus 3y. And so think about if it was 4y plus 3y. We all know 4y plus 3y. You're going to take those two numbers and add them together. 4 plus 3 with a y behind it. So I know nobody would do that. Nobody would write that second step, but that's what's happening. You're taking whatever the two numbers are and adding them together and putting a y behind it. That's the exact same thing that we want to do. So, for example, if you had star y plus smiley face y, I don't have to know what those two numbers are. I'm just going to add whatever they are together and put a y behind it. Okay? So that's exactly what we're going to do here. If I take xy plus 3y, I'm just going to add whatever those two numbers are. Maybe it's a 4, maybe not, I don't know, and put a y behind it. And so when I have to do xy plus 3y, I'm going to get x plus 3 with a y behind it. So carrying everything else down, minus 5x equals, this was canceled, 1. So I'm going to get rid of all this stuff right here. Let's move this up to the top. And I only have one y variable, so this is going to be pretty easy for me to isolate. Let's add the 5x over. X plus 3 times y equals 5x plus 1. And divide by the x plus 3. I'm trying to isolate y. Y equals 5x plus 1 over x plus 3. Or in function notation, I have my inverse. F inverse of x equals 5x plus 1 over x plus 3. And of course, x cannot equal negative 3, because that would give me 0 on the bottom of a fraction. So this last little bit, it says a lot of words, but basically what it says is if you know that some point AB is on the graph of a one-to-one function, then you can just interchange x and y, switch x and y, and it's on the graph of the inverse. So they kind of describe a picture, and they're saying that if you've got some point on a function, that it's going to be reflected over the mirror y equals x. And so what I would look at something like this. You have y equals x acting like a mirror. And so just picture like a parabola or something. Let's say we have a function that's a parabola. Then every point on this parabola would get mirrored over that line y equals x. And so this one over here, and there's a point like right there, and this point would be over here, let's say. And so you should be able to imagine what would happen if you took a mirror image of that parabola. It's going to look something like this. And so I know there's a lot of words, there are a lot of words in that thing, but really it's just talking about how the line y equals x is going to act as a mirror for the function to make the inverse.